Guys, here's the machine. It's in the almost finished state. It's a little bit dark. Better at this position. And in this episode, I will introduce the implementations of the cooling or air mist, and all the lines were made. And here is the lamp. And for here, I take it out. And in addition, there is the air suction, vacuum air suction for cleaning purpose, not for mounting workpiece purpose. And here is the control panel, and there are some switch here, and these two lamps, and this is the coolant. You can see here coolant, and this knob or volume include the on-off switch, and when it's on, when it's turned clockwise, it will tap. It will turn on the cooling pump, and also the volume will increase the flow rate of the coolant. And also this lamp was turned on. It's not clear. And this switch is for the compressed air. Compressed air come out, and also the lamp is turned on. You can hear the sizzling sound. Compressed air come out here of the mist coolant. And all this implementation is through the magnetic control valve here. You can see when I turn on this, a red light is turned on. And here it's not here. This line you can see here the light turn on, it's off. And the vinyl chip is connected here. This is for the coolant, and these two lines coolant, and this is air. For the no use port, I close it, and only use one in and one out. This actually is a 2 in and 3 out. Actually, I can use same tap as this, but I bought this so I make use of it and don't waste it. And as well, this is the spindle. There's no problem here. I can turn it on, run. You will see I protect it with the cover on the cooling cutter. It's very sharp. Now I go to, and one additional thing is the vacuum cleaner here. This is the vacuum cleaner pipe, and in here there is additional switch here. This is the on-off for the air cleaner. You will see suction air here. And turn off. Actually, there is the volume control for the maximum and minimum, but I haven't implemented that. And then go to the back of the machine. very clear because the limit space I can't move my cell phone in a good better position. And one thing is there is a bottle here. This is the cooling liquid, and the main item is here. This is the water tank, and the coolant pump is under here. This whole item is spring from my old machine. Actually, it is stored at the lower level. I built it for a long time, and it works for almost 6 to 8 years for the pump, and no problem. And the construction also no problem, except I replaced the tank. The original one is a hard plastic material, transparent material. The original one is for the storage of the camera. Is the storage camera cases, and it broke and cracked this as the oil attacked the polycarbonate or PC material, plastic material. But now I changed it into a very common use. This polypropylene soft plastic material is better, and this type of storage tank is very popular now, and there is seal around on the top, and you can see I close it, these two opening. Originally the water, the coolant will be flow down from the correction tray, and there is two pipes to drain the coolant down into this tank, and I close it with a paper to prevent the liquid vaporize. And I haven't built the tray under the machine yet, so I just pouring the cooling liquid there, and on the bottom you can see water pump is not expensive. I bought it a long time ago. It's I think 9 to 12 volt DC. And I open up this lid. You can see inside. There is the filter. Actually there are two, I don't remember, 2 or 3, and also the common outlet here. There is a blue color, or it is not easy to, or is the white color. There is a lot of small hole there. This is a small plastic bottle. Inside this bottle is also this type of filter. This is just normal aqua tap filter, and inside there, and then the coolant will go into it, and then come out from this part. So the common cooling liquid is clean, It's absolutely clean, and I never found there is a corkage on my nozzle. And here, this is also a storage cooling bottle. It's just easy to be built, and I will explain the purpose of it. And to run the DC pump, there is a control here. There is a transformer inside, a circular tap tutorial transformer to provide the 12 volt or 14 volt DCs, and then this is a general tap DC to DC converter, and have the voltage adjustment. So through the variable resistor, and I take out the resistor here and then connect the wire and go to here, and there is volume switch VR to control the output voltage of here to the pump motor, so I can adjust the motor power. And inside there is also a relay, and the wire will connect to this, so the relay will turn on the or off the power supply. And here is the DC line. And for the vacuum cleaner, here is the 220 volt AC power from drawing the power from here, and this is also the AC line, and there is relay inside. Also, you can see here is the only 2 wire to control the relay on off, and there is the voltage adjustment inside. I built this myself, and this is just common circuits, just like the light dimmer, and use some simple circuits, but unfortunately the transistor was burned out, so I need to repair it. Actually, this type of light dimmer circuit is not good, and it used the chopping circuits to chop the AC voltage, so there is a lot of noise, but I include a line filter there. But anyway, I will repair it, or if possible I will change to a better circuit. You can still use just on off. And for the pipes connection, and coming out from this 2 valves, there is 2 line air compressed line in, and also the water pump liquid come out, go in here into this control valve. So once I turn on this magnetic valve for the coolant, this signal will open this valve as well as open up this relay, so the pump operate, and also the relay, the valve open, then coolant will continuous flow. And for air, there is also into it and come out here. So 2 in, 2 out, and 2 out is going to here. You can see 2 line. P is for, sorry, this is the coolant, and the air is transparent. No, there should be, the air is this, the air is here, transparent, no liquid in, and it will go into here and go into here, go to this cable chain and into here. For the coolant, it will come to this switch here. This is the main switch. This is the main switch, and they divide into two lines. One is go to the upper bottle storage, and one in with here. And this line will go into this cable chain and go to the nozzle. And this main switch on off divide. There is also two main switch here. Actually, I should use this type of switch, but I haven't. I use this type of control tab. It's not very good, but still work. I may change it later. So I now to test its function. So firstly, I operate the coolant pump, turn it on, and you can see coolant come out here, not very strong, and I can turn it. So this decrease. This type of coolant pump or liquid pump is piston type, so you can see if it is in low power, you can feel there is pumping action. It's not very continuous, but no problem. I think one thing is need to take care this valve. The first time I didn't lock it tiny there, so liquid come out here, leaks it, and it's dangerous. It will flow into the control box. Actually, I don't have to install this liquid valve here and on the machine, but I want to make all the connection together here, so I choose here. Anyway, this box will be turned upside down, so even though there is leakage, it will come in this direction. But now is no problem. Even though I turn it into the maximum position, there's no leakage. So I turn it off. This is the air. There is air out, but there is no coolant. This pipe is in the upper position, so it's not going into here. I can move it down into here. There is two positions for the. When I am not use it, I will take it upper position, and I will. So I now test the mist coolant, and I need to here that I introduce one more thing here. There is some junctions, pipe junction here. These two lines, one is coolant, one is air, transparent, one is air, and it will go to the. It's directly go to this mist cooling control for the coolant. Oh, there is some leakage here. I need to. It's not quite good. I may need to change this type of switch. It cannot withstand high pressure. Anyway, I just test the circuitries first, and the green liquid line here, and it will go to this switch main input inlet and 3 outlet, and one left right is the coolant nozzle. So now I turn it off, and the central one is for the liquid. This pipe is for the liquid into this mixed coolant. Now I need to turn this valve. If I use the mixed coolant, I will turn off this main switch and also turn off this turn on this switch in before I close it. I now turn it on, so the cooling reservoir in this reservoir will flow down by gravity into here, but not to the tank. Instead, it will go to this line in the machine and go to here. Now the liquid coming into here is supplied from this reservoir by gravity, and then go to center switch is open and go to this mixed coolant. So I turn on this liquid. There is coolant. I will control it to very little amount, minimum around just, you can see it's very little amount. And I now turn on the air. So there is mist coming out, and this will cool the milling cutter. And here I can adjust the air also. So in this manner, I just use the reservoir here, and the liquid going down by gravity. Actually, this type of mixed coolant, it don't need use gravitational force. It just use the suctioning force to suction the liquid. Anyway, because there is another purpose of this, I just now turn it off first, and turn it off this here, and turn on the left and right coolant nozzle. And now this coolant nozzle, the water coming out is from this reservoir, and you can see here there's liquid coming out here. And here the green liquid is dripping out, and so the consumption is little. And in before, I use this mayonnaise in this machine for milling purpose, for small milling cutting purpose, example engravings, 2mm or 1.5mm, even though some 1.2 or 0.8mm engraving. So I don't need a lot of flow of coolant, and in this manner is enough. And also if I have two pieces nozzles, it can go in two sides, and in this manner I don't need to consume any compressed air or electricity of the cooling pump motor. I just use the gravitational force. So in most time of my cutting, I will use this type of cooling manner. And that's all for now for this episode. And thank you for your watching. If you liked it, please thumb up and subscribe. I experienced some further upgrading of my circuit board, and here is two relays for controlling the coolant, fat coolant. There is the liquid, and the compressed air. Compressed air is for the mist coolant. And the circuit diagram is reference to here. This is my original or old machine, high EZ 400 router machine. And you can see this part, and the two relay is here, and there are two transistors here. And when there is signal from the controller, here come in high signal, it will turn on this transistor, and current will pass through here and will connect the switch. In here, the original machine, it will turn on, it will connect the AC power plug. But in my one, I will connect the 12 volt to the coil of the air control, or like the valve. Yes, the valve, the coil of the valve. I have the two valves. They are the air valve, but one is used for compressed air, one is I use it for the liquid, the coolant. So this will turn on the coil of the valve. They are the magnetic valve. And here similarly is for the coolant. And additionally, there is a manual switch here, you can see. So I always also do this. For this switch will be allocated on the panel, control panel, so I can toggle the switch whenever I want the operation here or here. I can done it manually. And here is for the control box signal, or M5 or M8, the G code to control. And these two relays are 12 volt relay, and this coil to be supplied with electricity of 12 volt. But here you can see there is a further small relay here. The reasons for here is to at normal, when the machine turn on and in normal condition, this relay will be closed and 12 volt will be supplied to them for whenever for them to be on at the standby position, standby operation. And this relays have its code here. It write down 5 volt, but in my new machine is 12 volt. This is positive voltage. Here it will normally connect to the earth, so it will connect this switch so electricity can supply to these two relays. But actually this is connect to enable, or you can see this is enable signal. I'll go to another page. Sorry, there's something wrong. And here the enable switch is connect to the external emergency button. So at normal state, this voltage, positive voltage, will go to the enable that will have electricity to the little micro switch, small relay. So when the emergency switch is pushed, it will disconnect and everything will turn off. So here I've done the hardware here. In my original circuit box, there are two relay. It's marked P for coolant pump. Actually, this will turn on the coolant pumps and also the coolant valve. And this relay will turn on the valve for the compressed air. And this here, the two transistors here and two down here, and the signal going to the transistor is from here, from these two connector, and the center one is ground, and here this one is K is key switch. That this two will go to my panel, have the key switch, toggle on off switch for the pump or coolant and for the compressed air. And here is the signal going to the control board for coolant pump or valve and the compressed air valve. And another is the little small relays for enable. There is no space here, there is no further space here, so I make a separate board. And here you can see there is a connector here for here, and also here, connector here. And this is the small relay, it's 12 volt. And here is the enable signal, EA, and here is ground. Whenever there is actually it's in my new machines, my emergency switch is don't like the the, the emergency switches of my old machine. They are not connected in series, they are connected in parallel and in normal open stage. So in here I make some adjustments. I connect this small little relays in normal closed stage to suit for it. And this is the enable signal coming here, and here is the P. There's the here is the this. Let me think about it. Oh, this is the connection coming out from this relay, and this P will go to the valve coil of the coolant pump or the coolant pump or the coolant pump motor or the coolant valve, and here is A is to the coil of the magnetic valve, and this is the ground. So there is 12 volt coming out here, and here is the signal. One is from the on-off switch on the panel. One is from the control circuit for M5 or M8 G-code signal to control it. And here I can assembly it into the main board. Anyway, it's a little bit tricky, and the long pin a little bit deformed. And here I assemble it to the main board.